Good day. I'm going to discuss multiple access concepts. What is multiple access? Multiple access allows multiple users to communicate over a single channel by sharing a finite amount of the spectrum. Multiple access is the application of multiplexing, hence the similarity of its definition. Access methods. Access methods are the ways in which many users share a limited amount of the spectrum. It answers the question, how is the spectrum shared by multiple users? Access methods are similar to multiplexing methods. The techniques include frequency reuse, FDMA, TDMA, CDMA, OFDMA, and SDMA. Frequency reuse. It is when same frequencies are shared by multiple base stations and users. This is possible as long as users or base stations does not interfere with one another. To prevent interference, low power and lower height antennas are used. This restricts its range to prevent overlapping of signals. Base stations must have enough space from each other. Radiation patterns of antennas is also considered. Most base stations use sectorized antennas with 120 degrees radiation patterns. Each sector transmits and receives over the same frequency, and the sectors does not affect one another. FDMA, short for Frequency Division Multiple Access. Visually, it divides the frequency axis into non-overlapping channels, each to be used by one user. In the frequency domain, FDMA looks like this. Here are the channels. Each channel is given an assigned number or is designated by the channel center frequency. Each channel takes up a bandwidth. To prevent interference, there are guard bands in between the channels so no channels would overlap. TDMA, short for Time Division Multiple Access. Visually, it divides the time axis and time slots are allotted to multiple users. In here, different people use not only different frequencies but different time slots as well. Thus, unlike the 1:1 user to channel ratio of FDMA, TDMA has multiple users in one channel. TDMA can house multiple users in one channel by 1. Relying on digital signals and 2. Having high sampling rates. TDMA relies on digital signals because digital signals, unlike analog ones, can be compressed onto a single channel. TDMA uses high sampling rates so that one channel can alternately accommodate each caller in its allocated time slot. Let us look at how TDMA works in the time domain. Suppose we have 3 users per frequency channel. As time passes, the transmitted signal would alternate between 3 signals. Overall, the transmitted signal will be composed of different signals. When received, the time slot allocations will be used to separate and recover the 3 signals. There are 2 common TDMA systems in use. The first one has 3 users per frequency channel, and the second one has 8 users per frequency channel. CDMA, short for Code Division Multiple Access, and is also known as spread spectrum. Spread spectrum because it spreads the bandwidth of the input data, as in the transmitted signal will have a higher bandwidth than the input data. CDMA can be visualized by adding one more dimension to our graph, which is code. In CDMA, even in the same frequency and time, users are distinguished by codes. CDMA has 2 approaches: FHSS or Frequency Hopping Spread Spectrum and DSSS or Direct Sequence Spread Spectrum. Between them, DSSS is used by a higher percentage of cell phone systems. Let us try to understand how CDMA works. There are 2 pairs of phones communicating with each other at the same time and frequency, whose line of transmission intersects one another. There then arises a need for a way to distinguish them and prevent interference. CDMA essentially puts a lock on these links between the communicating devices, and the receiver side has the key. Each lock and key pair is unique, so that when a receiver accepts a different signal, it cannot use its key since the key is not meant to be used for this signal. The lock and key pairs are essentially the codes that distinguish the links from each other. Now, let us see how exactly does DSSS transmit signals. Suppose we want to transmit this binary code. Spreading code scrambles or encrypts the data input. The spreading code cannot just be made randomly. It is designed so that it has orthogonality. This is necessary so that signals does not affect one another. Since the spreading code changes more frequently than the data input, the spreading code has a higher bandwidth. Thus, the spreading code will spread the data input to occupy a wider bandwidth. The transmitted signal is the exclusive OR, bit by bit, between the data input and the spreading code. Recall that this logic operation is true when only one of the propositions are true. You may pause the video to examine how the transmitted signal was formed. Ideally, the transmitted signal will be the same as the received signal. Spreading code will also be used to decrypt this signal in the receiver side. Performing exclusive OR between received signal and spreading code brings up the original binary code. You may pause the video to examine how the message was recovered. OFDMA, short for Orthogonal Frequency Division Multiple Access. It divides a wideband channel into a large number of subcarriers. They can then be subdivided into smaller groups, and each can be assigned to an individual user. What is the difference between FDMA and OFDMA? First, both divide the frequency to cater to multiple users. However, FDMA has non-overlapping channels, and OFDMA has overlapping ones. This way, a frequency band is more efficiently used by OFDMA than FDMA, since OFDMA can have more channels in a frequency band. But it begs the question, with overlapping of channels, how does OFDMA prevent interference? The answer is orthogonality of the subcarriers. They are designed so they would cancel each other out and would not interfere with one another. In the frequency spectrum, the orthogonality of the subcarriers is seen such that the peak of each subcarrier occurs at 0 or at the null of the other subcarriers. SDMA, short for Spatial Division Multiple Access. This is actually an extension of frequency reuse. It uses highly directional antennas to pinpoint a user and reject all others even when on the same frequency or time. The area these antennas cover are very narrow. Thus, it locks in to only one cell phone user and it will be oblivious of other cell phones out of its range. Let us summarize the discussed multiple access concepts. Multiple access is the application of multiplexing that allows for multiple users to share a finite amount of the spectrum. Access methods are how the multiple users share a limited amount of the spectrum. Frequency reuse is using the same frequency for multiple users and base stations. FDMA divides a frequency band into smaller channels, each accommodating one user. Its channels are non-overlapping. TDMA allows for multiple users in one channel by assigning time slots to each of the user. CDMA uses code to distinguish between signals transmitted at the same time and frequency. OFDMA divides a wideband channel into a large number of subcarriers. Its subcarriers overlap one another. SDMA is an extension of frequency reuse and uses highly directional antennas. And that concludes my presentation. Thank you for listening.